Hello, I'm Al Sweigart, the author of Automate the Boring Stuff with Python, and in this recorded stream, I'm going to be refactoring some beginner programs and just going over the common pitfalls that a lot of beginners encounter when they're starting to write code. So for this, I'm using this code. I've gotten permission from them to use their Russian Roulette game, which is here at pastebin.com, capital EXBDZ, lowercase pj1. I'll go ahead and copy and paste this into the chat room. Feel free to go ahead and send things into the chat room, ask questions. I have a bad habit of not paying attention to the chat room because it usually appears on my second screen instead of the main monitor that I work on, but I'll try to respond to any questions. And let's see, after this, I'll also be going through a Tic Tac Toe game that I wrote that I don't use classes or object-oriented programming for, and I'll refactor that to start using classes, just so that you can see why we actually use classes and why we have object-oriented programming and what the difference actually is. So let's go ahead, and I'm going to start with this program. I'm just going to copy and paste that. So I'm going to go ahead and run this program. So Russian Roulette is really just a basic game, let's say 3 people, where in real life you put a single bullet in a 6-cylinder, in a 6-chamber revolver and take turns pulling the trigger and then going on to the next one, and then the unfortunate loser gets shot in the head. Anyway, so on that happy note, here's let's see, Albert. I'll just use people from the chat room. So apt11 and Todd's bod. Perfect. Now the time to play the deadliest game. Oh, I think this might have been a problem. This was working before. I noticed that here, first thing, whatever editor or IDE that you use, make sure it has like a real-time linter. So a linter will point out any problems in your code. So for example, right here, it's complaining that we use the random module, but we never actually import it. So if you pay attention to that, you can often find a lot of bugs in your program before actually having to run the program and then finding the bug. So let's go ahead and add that. Okay, let's do this. 3 players. I'll put me, apt11, Jamae plays. And thanks for the follow, Agent546. So right here, it's click, so then it moves on to the next person's turn, and it basically has just a 2-second pause for each of these. Nice. And then it goes back around. I wonder if I copied and pasted this to pastebin correctly, because I know it worked. Oh, that's 5 in a row, so unfortunately, I don't think this is going to work. Oh. You know what? I don't like this program anymore. Okay, so would you like to play again? Let's go ahead and select no. So you can probably figure out, like, okay, this program, has a random number that maybe like 1 to 6. You enter in how many people are playing and they each have names and that sort of thing. Let's go ahead and take a look at the code. Now, if you'll notice, this is a lot of code for this program. It's almost 650 lines. In the refactored version, I got this down to 50 lines of code. And I will go through step by step of first explaining how this program works and then how we can improve it. So let's see, we have a slot right here, which basically shows the different chambers of the revolver. So 5 clicks and then 1 bam. There's a lot of messages that it randomly shows if you've died or if you've survived. And then there is a welcome function, which displays the start of the game and lets you enter how many people are playing. And then there is a play function, which is the actual game itself. Now, one thing that I've noticed is that there is a lot of repetition in this code. Sort of like all of this code looks very similar and almost an exact copy of all of this code. And this is an example of something that I call choose your own adventure code. So when people first learn how to program, they really don't understand data structures, but one of the first things that they learn is flow control. And flow control statements are things like if else or loops or function calls. Basically, when you write a program, the execution starts at the very top and it executes the first line, then it executes the second line, then the third line, until it gets to the bottom. And that's the flow of execution. It starts from the top and goes down. And of course, things can change that flow. If you have if-else statements, then you can skip some blocks of code and run others. If you have a loop, you can repeat a block of code over and over again. Or if you have a function call, the execution can move to a different part of the program and then move back to the original calling, the line that called the function. And so that's a fairly easy concept to understand, like flow of execution. So what a lot of beginners do is they tend to rely on flow control statements rather than data structures, because data structures is usually something that's covered later on. So what you end up doing is creating a lot of code that is needlessly repetitive. And so now that I've explained that, let me show you what I mean. Let's go here. Actually, let me go ahead and start with something else. So here we have welcome to Russian Roulette. I'm gonna, let's see, people count. So here's some code where you can enter the number of people that are playing this game. And of course they have it so that if you enter some number that is not between 2 and 6, then it will ask you again how many people are playing. So notice how this line is pretty much an exact copy of this line. So notice that there's duplicate code here and here. Duplicate code is usually something you want to avoid. Oh yeah, that's right, Todsbod. Time.sleep is basically just a pause function. The nice thing about time.sleep is that it doesn't take up the CPU. Your process will actually make your Python program not do anything. So it's not sucking up CPU time while it's waiting. It's not like it's going into some infinite loop that doesn't do anything useful. The underlying Python interpreter actually gives up control to other processes on your computer. But it's just a nice way to introduce a pause, or in this case, just adding some dramatic tension and suspense. Duplicate code is something you want to avoid, because generally whenever you have to make changes to your program, either for bug fixes or you're adding new features, if you're changing one part of the code that's duplicated in other places, you have to make those same changes in every single place. And if you forget to make that change, or you only make it in like one place but not in other places, then the bug fix doesn't get applied to every place where the bug is present. And ideally, you want to have as little code as possible. Having less code makes it easier to reason about your program. Just like, reading a short Dr. Seuss book is a lot easier than reading War and Peace or some other like really lengthy piece. So you can always look at duplicate code as kind of like a code smell is the term. Where it's sort of like, this isn't necessarily a problem, but, if you can smell, if there's a funny smell, then there's probably something that needs to be cleaned up. So let's go ahead and change this. I'm going to make this first an infinite loop. And then I'm going to get rid of this part and just have it so that this code, instead of asking and then asking again in case they entered invalid input, I'm just going to ask once inside this loop. And then I will say, hey, if people count is between 2 and 6, and actually there's a way that in Python you can chain these together like this. And in that case, I'm going to break out of this loop. So this code runs if the player entered a number not in between 2 and 6. So this is a really common thing where I have an infinite loop, I get some input from the user, and then if it's invalid input, I just loop again and ask right here. So you can see now we only have this line once instead of multiple times. Here, I think this is actually a bug right here. So what a lot of people don't realize is that you can actually put else statements after a loop, like a while or for loop. And, oh, and let's see, in the Enraged Cracker says, why not do while? So in Python, there is no do while. So do while in a language like C++, I believe it's also in Java. I don't know, it's been a while since I've worked in that language. But do while essentially says, hey, run all the code inside this loop, and then after the first iteration through that loop, check the condition. Whereas this one will check the condition first. And here the condition is true, so that basically means that the loop will always loop continuously until we break out of it. Okay, so this while loop, you can actually have an else after that. And I think this was actually a mistake made on the original author. The else loop will run if the loop finished without a break statement breaking out of it. So it's kind of like how try and accept, the accept clause or the accept block has some code that runs if an exception happens in the try block. Let me go ahead and bring up the Python interactive shell. So we had something like this while true, and I'm just going to have this immediately break. We can also have else print. I forget the exact logic. Was it if it does break or if it doesn't break? This is the else block. Yeah, I don't always remember every exact thing about Python's syntax or its standard library, but that's okay. It's really easy just to open up an interactive shell and then type some code and experiment with it. Oh yeah, okay. So the else block only runs if this loop did not have some sort of artificial break in it. Whereas if we had something like, let me set I equal to 0 while I is less than 5. Let's do this, print I, and then increment I by 1. And then in this else, this is the else block. So you can see right here, this loop stopped looping because the condition became false. And because it didn't break out of it, it just stopped because it was false. Then the else block runs the code that's in there. So this is actually this is a feature that's not really used all that often. So I'm guessing that they probably like put an if right here and then later changed it. But at the same time, it still worked. But anyway, I'm going to get rid of that and then basically select all this code and move it down one level of indentation. Okay, so let's move on. So you've entered how many players are playing in this game. And let's see, now you need to enter their names. So you can see what this person has done is that they've created a bunch of variables called person1 for the first player's name, person2 for the second player's name, and then person3 and person4. And not only that, but they've also created a whole bunch of if-else blocks right here for every possible case. Now, here's one more code smell. Whenever you have a bunch of variables and you find yourself naming them like something1, something2, something3, that's probably a sign that you can use a list data structure to store all of them. And lists are way better than just having individual variables for all your data. So like, let's say I had, I don't know, I had a bunch of variables for my cats. So I had cat1 is Zophie, cat2 is Puka, cat3 is Simon, cat4 is Fat Tail. One day I will have this many cats. This is actually kind of hard to work with because let's say you want to get rid of one of your cats. Sorry, Simon, I'm going to delete that. But now you have to write code that deals with this gap in the numbering, and if you wanted to print all of the cats, you would have to write code that's very particular about which variables you're printing. It would basically end up looking like this, where it says, hey, if people count is greater than 2, then we're going to display the third person. And if it's greater than 3, we're going to display the fourth person, and so on and so on. So the best thing to do here is let's just create a list called cats, and then we can just append all of these cat strings here. And what's really nice about lists is, if you think about it, lists allow you to use code and data on your data, because the way that you access individual items inside your list is with the square brackets and then using the index. And you might think, okay, well, what's the difference between cats 0, cats 1, cats 2, and, you know, just having separate variables like cat 1, cat 2, cat 3. And the difference is you can now do things like have a for loop, which, you know, originally we're doing something like printing this, but now you can have that for loop and the I variable working on your data structure. And in fact, if we change this to say, hey, just go through however long cats is, that's how many iterations we want to do, this code will work no matter how many values are inside the cats list. So this is a good example of using a data structure to save yourself a lot of code. Let's see, another thing that they did is they started using a bunch of global variables. You might have heard that using global variables is bad, and I can go into that later. But here, I think usually we declare the global variables at the very top of the function. I'm actually not even all that certain that we need functions here, but I will handle that later. Let's take care of all these person1, person2 variables. And let's see, technically we don't need this if, because by definition we know that people count is going to be greater than 1. So this is always going to be true because of the code that we've written here. I mean, the code won't get out of this, won't get past this loop until we've gone, until it's been set to 2 or more. So because of that, you know, this isn't really even necessary. So we could totally get rid of this and then select everything in here. Really? Everything? Yeah, all of this, and then de-indent that one more time. And that's another code smell, is when you see lots of indentation start building up. This might be a sign that you can probably figure out some way to break up this code. After a while, you know, it becomes sort of actually hard to read this code, because especially if you have like a very small window, and it'll start like wrapping around where you can't see all the code all at the same time. So let's see. Another thing right here, oh, they do have a list right here for choose person. But the thing is, they're constantly overwriting this instead of just setting it up once and then appending it. So what I'm going to do is I'm going to replace all of this with a loop. So this is another instance where you see a lot of repetitive code. It's always person equals input, choose person equals something, and that was inside of an if. And then you see that repetition here, and here, and here. All that duplicate code is a sign that there's probably a better way of rewriting this code. And I'm going to do that with a loop and a data structure, a list in this case. So let's have a for loop. I'll just say for I in range. We want to do this, let's see, we want to enter each friend's name. And we know how many friends we have because that's the number in people count. Oh, one thing I'm going to have to do is remember input always returns a string no matter what they type in. So even if you end up typing in a number like 42, input is going to return the string 42, not the integer 42. So we can't do numeric comparisons with less than or equal to with that. So I'm going to go ahead and take the string that this returns, we're going to pass that to int, and then the integer that int returns, that's what we're going to assign to people count. So we're going to loop people count number of times, and then I'm going to call input. We'll have a little prompt right here that is going to be the string I. And so you can see right here, this code does all of this. It asks when you're asking for person 1 or person 2 or person 3 or person 4 and so on. We can do all of that with just these 2 lines of code. Now we need to find the string that input returns, and we need to do something with that. So what they're doing right here is putting it in a giant list called choosePerson. So I'm going to, before the loop starts, I'll set that to a blank list, and then we can call append and take the value that's returned by input, the value that the player typed in, and we're just going to append that to choosePerson. And those 3 lines basically replace all of this. Now the linter is now complaining because I've also deleted all of these person 1, person 2, person 3 variables, but that's okay, we'll fix that later on. So again, whenever you see duplicate code, that's probably a sign that you can change it, often by using some sort of data structure and a loop, or I don't know, just try to think of where is the duplicate behavior and what's the general pattern. In this case, it was, oh hey, I always say person number and then the number, and then we always add that to choosePerson. So in this case, we can replace it with this one line. You know, I could make this a little bit easier to read just by splitting it up into two different lines. Here, I'll just call it name, and then we'll just append that name. Okay, next we have some code that says welcome to all of the different players. And then, so the original author thought, well, you know, depending on if there's 2 players or 3 players or 4, 5, 6, they're going to have to print out different print messages, different welcome messages right here. And you can see, yeah, you know, when you have your variables split up into multiple variables with each ending with a number, this is the sort of code that you have to end up writing. So instead, I'm going to put this all in one line of code, and I'll be using the join method. So another common beginner pitfall, and this is just sort of unavoidable, but it's trying to write code that does something that the standard library for your programming language already handles for you. In this case, you don't need to do all of this separately yourself. If you have a list, you can just combine all of those. You can join them all together into a single string with the join method. So the join method is a string method. You call it on a string value. That will be the joiner right here. So you can call join, and then you pass it a list of strings. Sophie, Puka, Simon. And the join method will return a single string that has inserted this joining string in between them. And this is really nice because we have 3 items in this list, but we only need 2 of those joiners. We don't want to have like a comma at the end of this. And originally you might think like, oh, okay, well, I'll do something like for name in this list, print name plus, and then that joining thing. But this actually doesn't work, or rather change that so that we don't have a new line at the end of it. But this gives you an additional comma here, whereas join only puts it in between each of the strings. So let's go ahead and use join here. What we're going to do is say welcome, and then I'm going to do this. Join. Remember, all the player names are, oh, here in choosePerson. Now this doesn't exactly do the same thing because we have this and right here. And this is only going to put a comma. Let's say we had choose person was equal to these three names. This code would do this. Welcome, Zophie, Puka, Simon. It doesn't have the and word in there. That's fine. We can just go ahead and join everything up till the last string in the list. So this is called a slice. Normally when you have the square indexes, or the square brackets and an index, it just picks out a single value, but with the colon, we can pick out multiple values, and this will evaluate to a new list object. Now we want this will have two indexes. The first index is where the new list starts, and then the second index is where the new list ends. And it goes up to, but not including this index. Now in Python, this is really nice. You actually have negative indexes, which starts at the back. It's sort of like the reverse index. So -1 will be the last item. So this basically says, hey, start at 0, and then go up to, but not including the last item. And another nice thing is 0 is the default for the first index, so we actually don't need to type that in. So this will say just the first two names right here. Then we can add and choose person, and then we just want that last name right there. Now this isn't exactly the same as their code, because if we have choose person if that only has two names in it, that code is going to end up adding this weird comma right here, because that's what we have right here. I'm just going to go ahead and stick with that though, just so that we can keep moving. So let me do that. And that's basically replaced all of this code. Now another thing I noticed is that we have this variable, choose person num, which is set to 10. And I don't know why, but they have this reassigned to 10 in each of these. And I think that was probably just left over or just a copy paste error. But again, that's duplicate code. And so that's a sign that we should ask ourselves, do we actually need that code there? Okay, paying attention to the chat room again. Yeah, I used VS Code for a little bit, and I remember I ran into some problems with it and then said, oh, I'll just check this out later. I'm really a big fan of using text editors over a full-blown IDE, so I'm using Sublime Text, mostly because a lot of the Python projects that I work on tend to be fairly small and usually fit into a single file, so I don't really need a full-blown IDE. But really, yeah, whatever you're most comfortable with is the tool that you should be using. Oh, here's another weird thing that I saw. So we always set choose person num to 10, but then we immediately on the next line replace that with randint, and this goes from 0 to 1. And randint will include both the first and the second. So this is 0 or 1, and this one is 0, 1, 2. It picks a random number in that range. So it looks like choose person num. And again, we have this duplicated over and over again with just a slight change. So let's figure out the pattern behind this second argument. So whenever people count is 2, this is 1, and whenever it's 3, it's 2, and if it's 4, it's 3. So you can see that this second argument to randint is going to be people count minus 1. So let's go ahead and do that. 0, people count minus 1. So yeah, we've printed out the welcome message, and we've also assigned choose person num, which means we've basically replaced all of this code with these two lines right here. We also make choose person num a global variable. Oh, and choose person also has to be a global variable. So let me go ahead and put this right here at the top. I guess we can just put that all here. Oh, yes. Noise TV says I could also use an F string. That is very true. I'm used to not using F strings, even though it's a great feature, but it's only come about in Python 3.6, I believe. So even for people on Python 3, they might not necessarily be on a version of Python that implements F strings. F strings are really nice. In fact, I'm going to go ahead and use F strings right here. So just like how raw strings have an R prefix, F strings have an F prefix, and this allows you to put the formatting inside the string itself. So I'm going to get rid of all this string concatenation. And instead, I can just put these values directly in here. I'll show you what I mean. Oh, I'll have to replace this because otherwise that confuses the parser. Okay, so in this case, we have one single string. It's an F string. You can tell by the F prefix right here. And it starts here, and then it ends right here. But it also contains these curly braces, and inside the curly braces, this won't be the text of a string, but rather it's Python code. It's an expression that can be evaluated, and then whatever string that this, or whatever value that this evaluates to, will become part of the string. So F strings are a great way to replace string interpolation with a little %s, or string concatenation by using the plus sign to combine different strings. So you can see this code is a little bit cleaner. The only downside is they didn't introduce this until Python 3.6. Now, I've only written this code, I haven't actually tested it, so let me see if this runs. I think everything should still work. I don't have any linter errors anywhere else, so I'm going to go ahead and run this. Yeah, it seems to be the exact same. 3 lines. I'll just pick 3 random people from the chat room. Oh, here's a bug. It's person 0 instead of person 1. So let's go, we'll have to go through here and say, hey, person +1. Actually, here's another place where we can replace the string concatenation with F strings. I'll just replace that. Right here. And so the bad side about string concatenation is that if your value, like this I+1, if this expression isn't a string, you have to call string to convert it, which sort of throws a bunch of these stir calls everywhere. But with F strings, you don't have to do that. You can just have the expression by itself, and Python will automatically convert that to a string to inject inside of this string. So we don't want this to be I, because I starts at 0. So we'll just add 1 to it right here. And this isn't changing the value of I, this is just the expression, whatever I is, add 1 to that, and that's what we want to print here inside this string. So I'll just ignore that for right now. Let's just use some people from the chat room. Captain Green Owl and Bear Thrills. Hey, I think this actually works. I have the worst luck at this game. No. You know, I didn't really think about this, but it is very odd that a game of Russian Roulette has a part that says, "Would you like to play again?" I've just lost this game. I don't really think I'll be needing to play it again, technically. All right. Okay, this is great. So we've taken our 650 lines program, and we've gotten it down to like 610 lines about. So about like 35, 40 lines are now replaced. So this is pretty nice. You know, what calls this welcome function? We have our like main code right here, which sets play again to yes or to Y. And then this just keeps repeating as long as play again is set to yes, and they can change that here. How about this? I'm going to get rid of this part. Again, we have sort of like this setup right here. I don't know, I suppose this isn't really technically a best practice. This is just something that I like to do personally. I'm really a big fan of having infinite loops that we then break out of based on some condition. So instead of checking the condition right here, you can see that the original author had to add this variable right here just to make sure that this condition is at least true the first time so that it runs through this code at least once. But what I like to do is I will just cut this and make this an infinite loop. And then I will add an if block right here, and I guess if not all of this, so the inverse of this condition. So if this condition is true, then they do want to play again, then we do not break out of this loop, and we continue back here. So yeah, we basically just do this, the welcome and play functions. Let's go through here. Yeah, what are the odds that you'll shoot yourself twice in Russian roulette? I mean, technically like 1 in 36? Uh, or really 1 in 4 if you're playing with 2 people going back and forth. So hey, I like those odds. As long as you can guarantee that you'll survive the first gunshot, then, playing Russian roulette makes a lot of sense. Don't actually listen to me, people listening at home. So I'm not a lawyer or Russian roulette advisor. I am not a professional Russian roulette player, only an amateur one. Do not take this as professional advice. Okay, we have the play function right here. Let's take a look at what this code does. So you can see for I in range 7, which is interesting because that goes from, remember, range starts at 0 and then goes up to but not including this number. So it goes from 0 to 6, which is 7 different values. 0, 1, 2, 3, 4, 5, 6, and 6. Yeah. So I'm guessing that's, this is going to be for each, like, trigger pull is going to be all the code in here. Global choose person num. I'm going to move all of these global statements to the very top. I was almost certain that in previous versions of Python you had to have global as the first thing in a function, but I guess it's just you have to have the global statement before the first time you use it in the function. Use the variable in the function, that is. But let's take a look at this code. If people count, and notice you only need a global statement for variables that you change. People count, we're not changing that. We're only reading the value of this global variable. So it's fine that we don't have a global variable for it. So people count, which remember is the number of players, if that is int 2, oh, this is not necessary. Because, if we have the number 2 as an expression, well, that evaluates to the integer 2. But if we convert that integer 2 into an int, it's still just 2. If people count is 2, and if I, the loop variable, is 0, if I is 0, so on the first iteration, we say, okay, let's begin. And we say, it's choose person num's turn. And remember, this was set to a random integer between 0, so basically all the possible indexes of, not people count, but choose person, which is that list that contains all the players' names. Hey, how's it going? XXVMark. I'm working on refactoring somebody's Russian roulette game and just going through and pointing out all the beginner pitfalls that they've encountered, because I see a lot of code from beginners that are like this. A lot of it is just a lot of duplicate code. So you can see we have, okay, let's begin. It then picks a random number. It prints slot and then this number. What is slot? Oh, right, that was sort of the chambers of the revolver. So slot number, and then if slot number equals bam, then it shows a die message. It just prints that out. and then it breaks out of this loop. Oh, out of this loop. And that makes sense because after this loop, there is, I believe, nothing. Wait, what is that? Yeah, there's nothing, and so it just returns from the play function and says, would you like to play again? So let's go back up here. So if slot number equals bam, then we basically return from this function after printing out the die message. Otherwise, we print out the survive message. Not only that, we then increment choose person num. And then here we have choose person num. If that is equal to 2, we set it back to 0. And remember, this is the case where people count is 2. That is, we have 2 different players playing here. And this is for when I is set to 0, so on the first iteration of this loop. And next we have if I is equal to 1, we basically have the same code. It tells us whose turn it is, it checks whose slot number it is, and then if they die, we break out of the loop. Otherwise, we print one of the survivor messages, and then also increment choose person num. And we do that for the second, or I guess the third iteration when I is equal to 2. And then when I is equal to 3, I is equal to 4. So we see a lot of duplicate code right here. So whenever we see a lot of duplicate or copy-pasted code like this, where there's maybe just like one tiny thing that changes in each of these, that's a really big sign that we can probably use a loop or some data structure or something to get rid of all that duplicate code. And then I is equal to 5. You know, this is kind of odd because the last thing that they check is when I is equal to 5. But because of this, the last iteration is when I is equal to 6. So I think this is a typo. They really wanted this, going from 0 to 5. So you can see all this duplicate code, and then we duplicate all that code again, except this time for the case where there are 3 people playing. So there's the first iteration. We say whose turn it is. We determine if they get shot or not, and if they get shot, it disappears. Otherwise, we increment choose person num, and then also loop around. So there is a lot of duplicate code right here. And then we duplicate all of this again for 4 players, and then also for 5 players, and also for 6 players. And that's like the bulk of this program. That's why this program is over 600 lines long. Oh, right, Juicy Sword. Yeah, that's another thing that we can do. You don't have to do this, but it is kind of nice. If we ever find ourselves having an assignment statement that looks like this, where we have a variable equals that same variable plus 1, we can go ahead and use the augmented assignment operator plus equals. And this basically means, hey, whatever value is in choose person num, just increment it by 1. In fact, let's go ahead and find every place that we do this and do a find and replace like this, and replace all. Let's see, so there were like 29 replacements plus the one that I made. So there were 30 different places where we had that. That's not that big of a deal, but it is kind of more readable. That way you can understand, oh, I'm just making a modification to this variable. So one thing I've noticed that's different is on all the I, when I is equal to 1 or more, it says, hey, it's so-and-so's turn. And it also does that here, but only when I is equal to 0 do we say, okay, let's begin. So I'm going to go ahead and add some code right here. This will be the code that replaces it. Let's say if I is equal to 0, and then say, okay, let's begin. And then, because we display this code every single time, let's just put that inside this loop here. And so they had the right idea right here. Just say, hey, whoever's turn it is, in choose person, go ahead and print their name. Now the next thing that we do is this, number equals random number rand int 0 to 5. And I think this changes each time because this will be 6 different possible integers, 0 through 5, which is also the number of indexes they had here. This has 6 strings in it, so it's index 0 to index 5. But on the next turn, they only go from 0 to 4. Then on the next turn, they only go from 0 to 3. So if we think about this, the pattern that's in that code, if we just have this once, is 5 minus I. Because when I is equal to 0, this is 5 minus 0, or 5. And when I is 1, this is 5 minus 1, or 4. So we're just slowly generalizing all of the code that's in here. Next, we're going to go ahead and print the slot number. We'll need that. And here's another beginner thing. So a lot of code style stuff is just a matter of taste, but this is something that I'm pretty strongly in favor of. Never put a space between the function name and that opening parenthesis. Really, it's the parentheses that make us realize, oh, this isn't just a variable named print, it's actually a function that we are now calling. Because you'll always see the function name followed by parentheses, both when you're calling it and also when you're defining a new function right here. So that's pretty important. I'm gonna, normally I'm not such a stickler for a lot of code style issues, but this is something where it's yeah, it objectively looks better, in my opinion. In my opinion, it's objectively better. Let's see, we print that, we have another 2-second delay. And then let's see, we have this, what's the difference between this code and this code? It seems to be the exact same, yeah, bam, 0 to 5, sleep 4, and then break, 0 to 5, sleep 4. If choose person num, yeah, this looks almost identical here. So I'm just going to copy and paste this. And I think that basically replaces all of the code in this if people count equals 2 case. I think that changes when people count is different, when there's a different number of players. Yeah, because this one goes up to people count. You see this 3 right here, whereas it's 2 in our previous case where people count was 2. So the way that we can generalize that, the pattern there is that choose person, if choose person num equals people count. Is that true? Let's check down here. So if people count is equal to 4, then yeah, it compares it to 4. So we'll just do that right here. I'm kind of cheating because I've already run through and refactored this a couple of times in preparation for this stream, so don't believe that I have some magical clairvoyant power to understand all the changes that we should make. It's really just sort of an artifact of me working through all of this code before. It's sort of like how in cooking shows they always put all the ingredients together and then put it into the oven and then pull out the already cooked one from the same oven in one go. That's just me doing that with code. And I think this is it. I don't know, I feel kind of nervous about deleting this much code. But yeah, I think that's it. So with all of this code right here, we can now get rid of, this is for 3 players and 4 players and 5 players and 6 players. We can get rid of all of this code. Just delete that. So now we've gone from 650 lines of code down to about 60 lines of code, which makes this program a lot easier to reason about. Imagine if you found a bug in your original code, I don't know, say like, oh, bam, I misspelled that or something like that, and it was in every single misspelling. Every time you copied and pasted this code, it was in each of those. You would have to make changes to every single one of these lines of code because it's all duplicated throughout your program. And if you forgot to change one of them, then the bug is still there, but only sometimes, and it could be a real headache to figure out what's going on. Whereas right here, you only have to change it in one place. So all of these best practices for how to run code, because remember, the program that I have right now is pretty much, it does the exact same things as the previous code. It's just that now this code is a little bit easier for a human programmer to reason about. The computer doesn't care. Like, if you had a 8 billion line program that was all just copied, pasted, and everything, the computer really doesn't care. It's just going to run whatever code you give it. But, the human programmer who has to maintain all that code will probably pull their hair out because they have to, like, look through this huge, giant file. Just catching up on the chat room. Sorry if people have been asking questions and I've been ignoring them. Oh yeah, I'll definitely post the before and after. So, once again, I should do this. Here is the code on the original program on Pastebin. It's pastebin.com/raw. I'll put this into the chat room. Capital EXBDZ, lowercase pj1. So I think this is it. Now, I'm not certain that this is the same. Hopefully I haven't done anything that breaks this program. Let's go ahead and do this. So 6 players. Who wants to play? I'll just pull random people from the chat room. Juicy Sword, you're in, whether you like it or not. Bear Thrills. Sugar White. Luger718. Fitting. And Voodoo7175. All right, let's begin. Ignore all this. This is just because Sublime Text considers this to be, it tries to do Python code syntax highlighting, which is why it thinks like, oh, this is an unfinished string. And that's just, and also is a Python keyword. That's why it's a different color. Just ignore all this weird colorization stuff right here. Oh, and Bear Thrills was the one that lost. Yeah. So I think it keeps going until the first person gets shot. I don't think it keeps going until there's only one person left. Let me get the original code. Russian original.py. Sorry about this. A, B, C, D, E, and F. Right, and forgot about that. Import random. Okay, run this again. Tell you what, actually, just to make this a lot faster, I'm going to replace all of these time sleeps, these 2-second pauses with 0-second pauses. And all those 4-second pauses with 0-second pauses, just to have it immediately split all of this out. Here we go. A, B, C, D, E, F. Yeah, I think it only goes until the first person gets shot, so it doesn't go until everyone's been eliminated except for one person. But yeah, so we've now gotten rid of all that duplicate code, and this program is much more manageable to work with. So let me go through now and just find, I don't know, just to be a stickler, other things that I've noticed. The main thing was just getting rid of all those duplicated flow control statements, or what I call choose your own adventure code. Because when people are first learning how to program, they tend to think of programs as kind of like a flow chart where you're doing this and then you either do like option 1 or option 2, and then that works on other things. So it's a very like flow control centric way of thinking about programs. And what they don't think about, and what a lot of programming books don't really go into or explicitly call this out, is that you can have data structures that can fix or get rid of a lot of the duplicated effort that you have. So I call it choose your own adventure programs because, like those old choose your own adventure books, you basically start at the beginning and then you're just constantly hopping around the book, just like the execution is hopping around. Where really, if we just include some data structures, for example, the list choose person right here, and then write code that can just generically work on that data structure for a variable number of cases. And in this case, this code works no matter how many people are playing. In fact, there's no reason that we can't have more than 6 people playing. Well, actually, that's because players 7 and up will definitely not be shot. But you know, technically, we could have this this code right here could work with 100 players or 1,000,000 players or 1,000,000,000 players, whatever number. It's set up to be very generic. Nothing is really hard coded into the program, which is basically what we were doing right here. We were hard coding, hey, for the case where we have 2 players, run this code. For the case of 3 players, run this code. For the case of 4 players, and we have to do that for every single possible case. And in this program, you know, Russian Roulette, well, you know, there's only going to be a maximum of 6 chambers inside the revolver, so, you know, 6 cases isn't that much. But if we had more than that, we would end up having, you know, if you had hundreds or thousands of cases, that's a lot of code that you would have to duplicate. And to give you an idea of what I mean by this, I, as a joke, wrote this program called My First Tic Tac Toe. And I'll just post a link to that in the chat room. This is on my GitHub profile. This is just it's a tic-tac-toe program. Just uses text, writes out tic-tac-toe. The thing is, though, I've hard-coded every possible game of tic-tac-toe in here. So you play against the computer, it has an AI, and every single possible move that the human player can make, I've hard-coded a response to that, and then a response to those responses, and so forth, and so forth, and so forth, for every possible game, which ends up being about 18,000 lines of code. But hey, technically, you can run this. Like, if we just look at the raw code right here, and I copy all of this, and I paste it here, I'm just going to save this as test1.py. I can run this, and technically it works. Like, hey, we can go, let's start by going into the corner 7. And the computer, the AI has moved here. Okay, let's go into space 9. And then the computer has blocked us because it realized that we could have won there. How about space 1? And then it realized it had to block us there, but aha, we can go here. And now I can go into space 5. And I've won! Yay! So yeah, this was all written as a joke. I actually have a program that generates the source code to this, which you can see right here, this generate code for tic-tac-toe.py. And this is itself only... Oh, okay, I had like another joke where somebody said, oh, tell me you didn't actually write all that code out yourself. You wrote a program that generates all that code. And I was like, yeah, this program right here generates that source code. It opens tic-tac-toe.py, and then it writes this giant string that's 18,000 lines long. Oh, and my browser is broken. Yeah, it generates this code that prints out this multi-line string that's 18,000 lines long. Okay, no, the actual code generator is inside this folder right here. And this is only like a couple hundred lines long. Yeah. Yeah, don't actually write hard-coded choose your own adventure style code. I mean, if you take a look at this 18,000 line long program, here, let me go back to this. technically, this is all flow control. Like, there's no function calls, there's no data structures, really. Technically, there's no loops. It's all just if-else. Actually, I think it's just if. um, it's just a lot of nested if statements inside of each other. And so this is the kind of thing that we want to avoid doing. This is just a very extreme case. It's really easy because when you first start programming, you start thinking of programs like that. Oh, okay, the computer, I just need to program it to do this in this case, and then this other thing in this other case, and then there are some sub cases for that first case. We just add more if-else statements, and you end up hard coding a lot. And a lot of beginner programming guides don't point out, like, hey, if you have duplicate code, that's a sign that you can probably fix this. A common way of doing that is with data structures, and then you write code that operates generically on that data structure no matter how big that data structure grows in size. Or you can just like put code in a loop. So those are the major things with this program. I'm going to go through and fix some other things. Namely, we have a function call for welcome right here. We have this welcome function. The only time that we call this function is just once right here. And then the only time that we call this play function is just once right here. Now, functions are a great way of getting rid of duplicate code, where if you wanted to run all of this code like twice in two different places in your program, instead of copying and pasting that code, which gives you duplicate code, you could end up instead just putting that code inside a function and then just having two function calls. But really, if you only have one function call, there's no reason why you can't just put all the code inside play right here. So I'm going to do that. I'm going to just take all of this, copy this, and just replace play with that. I think I need to, is that indented correctly? Yeah, I think so. And this isn't inside of a function, so we don't need that global call anymore. So I'll just add a comment, play the game. Oh yeah, I would also go through and add a lot of comments to this code as well. And here, welcome is only called once, so we can replace this call to welcome with the code inside of welcome. Oh, not that. That's play. We don't need that anymore. Here, this code. We can replace all of that. Just add a comment here, display the welcome message. And this game is the exact same, except now, since we're no longer inside of a function, all of these are just global variables, so we don't need to have those global statements. Let's see, a couple more things that we can do with this program. This is very interesting. We have a slot right here. The thing about this list, we never actually change this list. There's no like append calls, or we never delete items from it. Really, the only times that we use this is to print either click or bam right here, and then check if it was bam, that's how we know that this player has died. Oh, one thing that I will have to change about this is, oh, no, I don't have to do anything. This break will break out of this for loop and then continue here. Let me just run this program one more time just to be sure. Let's say two people, A and B. Oh, this is a weird additional space right here. I think I accidentally did something like that. It's A's turn, click. Yeah, so Fink Daddy brings up a good point. We can turn this into a constant, and in Python, there's actually no difference between there is no difference between constant variables, and in fact, the term constant variable is sort of an oxymoron. But we can make it capitalized, and this is just a convention. It's not the Python interpreter doesn't treat this code any differently, but it's just a note to human programmers that, hey, this is a constant variable. The all caps is also used for global variables as well, so it could be one or the other. But that's basically saying, hey, this variable that we've stored this data, this actually never changes. So I'm going to go through, make these capitalized also. So that's just like a nice thing to remind us so that later when we're looking at this code, it's like, oh, slot, okay, that's a constant thing that never changes. And also, because it's constant, we really don't need to use a mutable list, and instead we can use a tuple, which is read-only. You can't make changes to a tuple value, but it is slightly faster to work with. So let me bring up the interactive shell. You can see right here, if we have a variable spam, let's say 1, 2, 3, we can change these variables to anything we want, and that's fine. However, if spam was a tuple, which uses parentheses, trying to change spam would raise this type error. So that's fine. Again, and performance-wise, tuples are slightly faster sometimes, maybe. The main thing is it's assigned to future programmers that like, oh hey, slot never changes. It's read-only. But let's actually look at how we use slot right here. So we create a random number, and then we print the random number is going to be an index into slot, and that determines if it shows bam, where the gun goes off, or click. But bam is always going to be here at index 0. So really, we could replace this code with something like this. If number is equal to 0, print bam. Else, print click. And that does the exact same thing that we did before with this code. And right here, we're checking, hey, if a slot number is equal to bam, that's how we know the gun went off. But really, we could just change this to if number is equal to 0. That's how we know the gun has gone off, which means we actually no longer use the slot tuple anywhere in our program. So that means we can basically just get rid of this. There's no reason that we actually need to store all that data right here. So, that lets us knock out, well, it added some lines of code, but it also let us get rid of a variable. So minimizing the number of variables that we have is kind of a good idea. I mean, don't go out of your way to like combine variables into one, but in general, like if you don't need it, then it's fine. We also have this where die message num, this is a variable that is very short-lived. We only assign it right here, and then we only use it once on the next line. This is more like a matter of taste, but we could just combine those into one. And I don't think, it's not a good idea to make super long one-liners, like a single line of code that just contains so much information, it becomes kind of hard to actually understand what's happening. In fact, maybe it's better to just have this as 2 lines, because it's easier to understand. Oh, die message, and we just print out die message num, that index, whatever string is at that index. But here's another thing, and this is just something that you would only know to do this once you become more familiar with the Python standard library, or the standard library of whatever language that you're using. Let's see, we can import random. There's a function in the random module called choice, and you can pass that a list. Let's see, A, B, and C, and it will return a randomly selected item from that list. So this is pretty much the equivalent of doing, something like this, where we have num random dot randint 02, and then having that list. So, except it does it in a smaller, less code. So really what we want right here is just print random dot choice, and then pass it that die message list. And this is the list of all these death messages right here. So now we actually don't use this variable anywhere else in our program. I can do a quick Control F for that, and we can see that it doesn't exist anywhere else, which means I don't really need it. So that's a line of code that we can get rid of. And we can do the same thing right here as well. Random.choice, and then get rid of this variable as well. And I've noticed something right here, we have if number equals 0 and then an else, followed by if number equals 0 and then an else. Let's just go ahead and combine both of these into the same thing. Like really, I could just move this code right here and this code right here. Although for both of these cases, we have time.sleep equals 2, but that's fine. I'll just copy and paste that after both of those cases. And then we can get rid of this as well. And so that's sort of merging these blocks together. I think like we've gotten rid of a few lines of code, but we also added an extra line of code because we now have to have this duplicated right here, but I don't think that's that big of an issue. Let's look at this. This code right here. So choose person num is incremented by 1. And then here we are checking, hey, if that choose person num, if the number is equal to people count, let's have it wrap around and become 0 again. There's another, if you ever do like this wraparound behavior, you can use mod to sort of replace all of this code with just like a quick one-liner. So here's how mod works. It's basically the remainder operation. So, you know, we have 22 divided by 7. That's going to be 3 remainder 1. But in this case, we have it be like 3.14. We could do / to do integer division, and that just gives us the 3. And then the remainder part will be 22 mod 7. So that's how we can see like, oh, this is, you know, 3 remainder 1. But the nice thing about this is, let's just print out a whole bunch of numbers from through 0 through 9. We can have this, we can sort of like limit a range of numbers from 0 up to 3 with this code right here. Or here, rather, let me do this. Let me print out 1, but also 1 mod 4. So you can see 0 mod 4 is just 0, 1 mod 4 is 1. That's fine until we get to 4 mod 4, that's 0. It's wrapped back around here. And then 5 mod 4 is 1. And you can see we have this wraparound effect. So how about this? Instead of choose person num, where we increment that and then wrap it around to 0, let's just do this. Choose person num is going to be equal to choose person num plus 1 mod people count. And this one line of code can replace the 3 lines of code that we had previously. Another small thing that we can do in Python code is here, where we're comparing if a single variable is one of multiple values. And whenever you do this, where it's yes, or yes with a capital Y, or just lowercase y, you know, if we wanted to be very thorough, we could just say like, or this is a capital Y, or if this is yes, all caps. Here's one thing we can do. Let's just go ahead and convert whatever they've typed in to uppercase, and then we only have to compare this against the possible uppercase values, which is really just if play again is equal to Y or to yes in all caps. And then we can still combine this yet again if we ever find ourselves checking to see if a variable is one of multiple values. Instead of, this is more of a Python thing than a generic programming language thing. Not all programming languages have something like that. We can use the in variable, or the in operator, sorry. And we'll just create a list that has all the values. And so now we're saying, hey, if this variable's value is inside this list, it's one of these values, then this expression will return true. So doing this in a list of all these values, that's the exact equivalent of play again equals yes, or play again equals y, or play again equals whatever else. And again, because we're not actually modifying this list, we don't really need a list here. We can use a tuple instead. So we can just simplify this code a little bit. Yeah, we've gotten this down to 54 lines when originally it was about 650 lines. Yeah, and this is another reason why lines of code is a terrible metric for progress. You know, because you can say like that day that I wrote this Tic Tac Toe program, I can say like, yeah, I checked in 18,000 lines of code today into the source control system. I've been very productive today. Not necessarily. It's kind of like judging a book by its word count. It's like, well, clearly a 600-page book is twice as good as a 300-page book. You have twice as much book. Just the same way, you can't really compare lines of code and use that as a metric of anything useful. Although there's project managers and programmers and others who try to do that. They say like, well, you only checked in 10 lines of code this week. Like, you've obviously been slacking. Well, no, it doesn't. You can't really use that as any sort of metric for anything. In fact, I remember you'll always hear anecdotes where programmers will say, well, the changes that I made to our source code ends up with like negative 50 lines of code. So actually I've done negative amounts of work. When really, cutting down the code by 50 lines and then making changes to other lines of code, that can be like an indication that you've really cut down on your technical debt. And technical debt, that's another term that's used by software engineers. It's sort of whenever you find yourself making shortcuts or just doing temporary hacks just to get your program running, that's fine. In the long run, like it'll make it hard. It'll make your source code harder to change or harder to read and modify. But if you just need to get it up and running and you don't really care how sloppy or hackish the code ends up being, we use that as like, oh, you're just adding technical debt. It's sort of like, you're buying something with a credit card. You will eventually have to pay that down by spending time and effort to actually go through the code and improve it. But you can do that later on. If you just need to like ship a program or a piece of software, you can increase your technical debt. A great metaphor for technical debt is Tetris. Specifically, like, if you find yourself adding technical debt or like doing like shortcuts is sort of like just throwing blocks down in Tetris. Eventually this might catch up to you, but later you can then work your way to reducing it back down to manageable levels. But technical debt is not necessarily a bad thing. In fact, it can be a really good thing. It's fine. You don't have to like, not every program you write has to be an utter masterpiece. In fact, if you're just writing some program that you're going to run once and then sort of never use ever again, it really doesn't matter. You don't have to use really, software development best practices for that program. It's fine. And in fact, most of the code that I write, and I think that most code that software engineers write in general, is going to be either replaced or just forgotten about within 2 or 3 years anyway. You can probably Google find this metric. I think Google says they replace like 40% of their code every year or something like that. It's like some surprisingly large amount of their code base, that they've paid very expensive Google software engineers to develop, and then they just end up getting rid of it and replacing it with something else later on anyway. So, that's a healthy attitude to take towards technical debt. So let's see, I'm gonna run this one more time just to make sure I haven't broken anything. I totally have broken something. What is this? Unexpected indent, line 38. There's an unexpected indent right here? Is this a tabs? Is this a tab spaces thing? No, I don't think so. Oh, okay. Oh, I think I forgot to save it before I ran. Okay, let's do this. 6 players. I'm just going to pull random people from the chat room. So Eric81, Casual Tommy SF, Suge White, Instant Mac. Who else wants to be in this? TWXGH. And, Captain Greenow. All right, let's begin. Click. Yeehaw. I ain't gonna die today. Yeah, I really like the 2-second pauses because it adds like a nice bit of suspense to this game and just kind of, there's no reason it has to be in there, but it's just kind of fun. Oh, sorry, Instant Mac. And no. Okay, hopefully I won't have to make any other changes to this, but I'm going to go ahead and post this to pastebin.com. Refactored Russian Roulette game. Create a new paste. And here we go. It's capital ZHLCF, lowercase x, capital G1. I'll go ahead and paste this into the chat room. So yeah, if we do a before and after of our two programs, here's the before, which has a lot of duplicated code in it. And then our later program, which is, almost fits on a single screen. That's pretty good. All right, so next, for the second thing that I'm going to do for this stream, I've been streaming for about an hour and a half now. I think I'm going to cut it off at 2 hours. I'm going to go through this Tic Tac Toe program, like a real Tic Tac Toe program, not my joke one. And you can find this here. I'll enter this into the chat room. Capital S, lowercase dq, capital JKL, lowercase qv. In fact, I think I already have it right here. So this is just a nice player versus player tic-tac-toe game. I'm going to run it and it looks like this. Okay, so what's X's move? Go right there. What's O's move? Go right there. Let's make this really short. Goes there, and then X wins it. So how this program works is that we have this tuple, all spaces, which we need, I think we usually, loop whenever we need to have a for loop go through every single possible space. And these are just the strings 1 through 9. And then we have constants right here for X and O and blank, which will be printed on the screen. That's just a capital X, O, and then a single space. And the reason I'm using this, like right here when we set turn and next turn to X and O, the reason I do this instead of, say, like this, is because if I happen to make a typo right here, like say I accidentally type P instead of O, this is still valid Python code. And Python won't notice anything's wrong, but it will definitely cause a bug and some error later on. But if you use constants instead, and then I made a typo right here, you can see even here in the linter, I don't even have to run this program. The linter points out, hey, there's no such variable named P, something is obviously wrong right here. And so you can catch bugs a lot quicker than if you had just started using string values. And when it comes to finding bugs, you always want to fail fast. You always want to have as little space or time between the actual cause of the bug and when you first notice the bug, because then it'll be easier to trace back through the program and track down the original cause of the actual bug. So let's see, we have a bunch of functions here. I have this. This is a Python convention right here. If we run this tic-tac-toe.py program from the command line, this special dunder name dunder variable, and we say dunder because it's double underscore. Dunder name dunder is a special variable in Python. It's set to this string value whenever this program is run from the command line or just run as a program. But if this file is imported as a module, the name gets set to, I believe, tic-tac-toe, just the name of the file. So we want it so that you can import this module and get all these functions, but it only calls main if we've actually run this program. I'll probably get rid of this because, I don't know, you don't have to have this. It's just kind of like a nice thing to have sometimes. But anyway, so main is where our main game of tic-tac-toe is run. So we can say it says welcome, we get a game board from get new board, and then we set turn to X, and then the next player's turn is O. We have this big loop right here where we draw the board, we get the player's move by passing it that board and whoever is has the current whose ever turn it is. We set that move on the game board, and then we check if the player whose turn it is a winner on this game board because they have 3 in a row, and in that case, we'll draw the board again and then print so-and-so has won the game. Remember, turn and next turn are set to X and O, these strings right here. Otherwise, if they haven't won, then we also check if the board is full, in which case we'll draw the board and then declare it to be a tie. And if that is also not true, then we will just swap turn and next turn. So then the current person's turn is going to be O, and then next turn will be set to X. And then we just loop back here to the start of this loop for another round of Tic Tac Toe, or for the next player's turn. So let's look at all the different functions that we have. We have draw board, we have get player move, we have get new board, is winner, and is board full. Now in this, let's take a look at get new board. Get new board creates a blank dictionary, and then it loops through all the possible spaces. That's 1 through 9. And remember, when we ran this, those are the labels that we have for each of the spaces on the tic-tac-toe board. It's kind of set up the same way that your keyboard's number pad is set up. Oh, what add-ons do I use for Sublime Text? Asks Jacob. I actually, sorry, I've totally forgotten this. I know it is... What? Okay, yeah, it's Sublime Linter and Sublime REPL. And you can find instructions. Sublime Linter is the thing that adds the little red dots. Like if I ever have something that's obviously going to be wrong. This is basically all the errors that can be detected just by looking at the code without running it. Those are the things that the linter can find for you. And usually it's great for especially for detecting typos in your code. So I have Sublime linter for that, and there's specific modules for Python and various languages. And then I have Sublime REPL, which adds the interactive shell, where I can run this, and it'll run the program. And then after this program completes, I have an interactive shell. So I'll just go ahead and close that. So let's see, we have all spaces. Remember, that's just 1 through 9 as strings. We're looping over all of those, and then we set the keys of this dictionary to 1 through 9, and we set a blank space, which is just a single space right here, as the value in that dictionary, and then we return that. So all of our tic-tac-toe boards are really just represented as dictionaries which have the keys 1 through 9, and then the value for that key is just the character that we print in that space on the board. So you can see later when we call draw board, we pass that same game board dictionary to draw board, and we just have an F string right here. You can see I print out, let's see, the 7 key, that value in the board right here, and then I have the little ASCII art of the tic-tac-toe board. And for 8 and 9, we have all of this. That's that horizontal line right here. And then 4, 5, 6, and 1, 2, 3. And then I have these numbers printed off right here just as a sort of guide. So you can see like, oh, okay, 7 is here in the top left. And then when it asks you for the move, it says, hey, just enter a number from 1 through 9. Okay, so that's very interesting. Yeah, all of these functions just work off of that game board dictionary. You can see get player move. We pass it the current board, so the state of the board, and also whose turn it is. If we look at get player move, let's see, we have a while loop, and we say, hey, what is player's move? And remember, this will either be the string X or the string O. And then we get that, whatever they type in, we convert it to uppercase, and we check, hey, is that in all spaces, and also, is that space on the board blank? And we'll keep looping as long as this condition is true. And once they enter valid input, which is, an actual space, and also a space on the board that's blank, that's when we break out of this loop and just return that space, which will be the string 1 through 9. So this is how we get the player's move. Let's see. Going through here, we can detect if the player is a winner just by I don't know why I called this Mark. We should really just call that player as well. But here, this is just a giant Boolean expression, really. We say, hey, if the, and I replace board and Mark with BO and M just so that these are shorter. We're going to say, hey, so if the 7 and 8 and 9 are all set to this player right here, or, the middle row, or the bottom row, or the left column, or the middle column, or the right column, and then, or the diagonal. Remember, 5 is right there in the center. So this is 7, 5, 3. Or the other diagonal, 9, 5, 1. So if any of those are true, then this entire expression returns true. So this is how we do the logic of determining if a player has won. So this returns either true or false based on the board and the player right here. And next we also need to check if it's tied, and we do that by seeing if the board is all filled up. And so we're looping through every single possible space on the board, and if any of those are blank, then we'll return false because the board is not full. But if we manage to get through this entire loop, we'll return true because we were unable to find any spaces that were false. And then set space right here just takes that board and then the space, which is the key, and then the mark, and then just sets it right here. I'm not even sure why I have this, because this is just a one-line function. We could just replace the one place that calls this function. But anyway, that's fine. Yeah, so this is it. It's nice. It fits in 80 lines of code, and it's just a simple tic-tac-toe game. Let's see what this looks like if we use object-oriented programming. And actually, I have a completed version of that right here. So I'm going to do this. I'm going to put this on the right side and then put this on the left side. So this is the non-object-oriented programming version, and then this is the object-oriented version. Let's talk about object-oriented programming. That basically means classes. We're going to start creating classes. Now, a lot of programming languages, in particular Java, which claims to be a purely object-oriented program, which means that all of its code belongs into classes. OOP and classes they're really great for adding structure and organization to your code. But if you're just writing a very short program, something like this tic-tac-toe game, which is just 80 lines of code, oftentimes you'll find you're not really adding organization so much as bureaucracy, if that makes sense. If you're writing a shopping list, it's fine to just grab like a scratch sheet of paper and then just like jot random things in whatever order, because who cares? It's just a quick shopping list. You don't need that. Whereas, if you're working in a chemistry lab and you had to have like a list of steps, you would want to take a more formal approach with that. That formal approach, though, for a shopping list, well, that's just too much effort for something that's not really worth it. The same thing with classes, I feel. Classes are a great way to tie together code and data and kind of organize your code. But for really small programs, you don't always need it. So the main takeaway that I want you to have is that you don't always need to have classes, or like object-oriented programming isn't automatically better. I see a lot of people, when they first learn about classes and OOP, when they start writing a new program, they're like, okay, I need to have a class for this and a class for this, and then this class inherits from this other class, and they create this entire like hierarchy, and it's a lot of structure and organization that they really don't need. In this case, using a dictionary for a tic-tac-toe board, that's pretty much fine. I mean, there are like cases where you could have an inconsistent dictionary, like what if this had like some other key, like we accidentally had some code that was like board 0, which is not a space on our tic-tac-toe board. Or what if the values for this key was set to something that wasn't X, O, and blank? In a small enough program, though, those bugs are pretty easy to find and fix. It's really once you get into much larger programs, it kind of helps to generate classes. So what is a class? Well, in Python, a class is the exact same thing as a data type. In Python, it is literally true. Here, I can bring up the interactive shell. Oh, let me catch up on the chat room. How would a Python dictionary differ from a JavaScript object? They're actually pretty similar. An object can also have, in a JavaScript object can also have methods, although technically a Python dictionary could also have quote unquote methods as well. Like, say if we create this hello function and it just prints hello. In Python, functions are first class objects. Like this hello, it's just like a variable that contains a function value, you can think of it as. And so you could even store this in a different variable, like store that function value in a variable named spam, and then you can just call spam. It's really the parentheses after that say like, hey, call this thing, the thing that's in the function value that's in this hello variable. And so we could also create here eggs equals this. We could use that as the value inside of a dictionary. Now eggs has x, and then we could then call that. Don't actually write code like this, because usually it's just confusing to do that. If you find yourself ever doing something like this, that's probably a sign that you should just go ahead and use classes. Let's see, what was I talking about when I wanted to bring this up? Oh yeah. Classes are the exact same thing as types or data types. Like data types, classes, all of those are literally the exact same thing in Python. In other programming languages, there might be a slight difference, but they are the same concept. So usually when we think of data types, we think of things like integers or strings or maybe Boolean values. And really all a type does in this sense is it defines a range of possible values. So for integers, there's, pretty much effectively an infinite number of possible values. 0, 1, 2, 3, some giant number like that. And the same thing with strings. You could have A or B or C or AA or AAA, A, and going on and on and on. As long as you have enough memory, there's basically an infinite number of values. For the Boolean values, though, there's really only two values. There's true, and then there's false. Now you can use the type function to return what type is this value. This is a bool. And then for the none value, the interactive shell, this is just a special interactive shell thing in Python. Whatever expression you type in here evaluates to none, it doesn't display it. Like, I can type in false, and it says, oh, this expression you've typed in evaluates to false, which is why I can do like false and true, that evaluates to false, and false or true, that evaluates to true. But none just evaluates to none, and then the interactive shell won't display that. But we could pass that to none, and none is the only value in the none type. And in fact, if you look here, the name of the function is type, but it returns these things, which are called classes. That's because classes and types are the same thing. Oh, right, Finkdandy brings up a good point. So there's also a concept of truthy and falsy values. So in Python, if you ever have something like bacon equals 2, if bacon print hello. Now bacon isn't a true or false value. It's, the integer 2, but 2 is considered a truthy value, which means, when used as a condition, it's considered to be the same as true. It's sort of like if we wanted to convert 2 to, if we pass that to bool, this would return true. The falsy values are going to be 0, and then everything that's not 0 or every integer that's not 0 is going to be a truthy value, which means passing it to bool will return true. So this is sort of like saying if bool bacon, then print hello. It's like, well, this is going to evaluate to true, and since the condition is true, then we go ahead and run this code. Let's see, the other falsy values are 0.0. None is a falsy value. Of course, false is a falsy value. Empty lists or empty strings are going to be falsy values, whereas like every other value in those data types are going to be true. So technically, this means that a blank string is false or falsy, but the string false is truthy, if that makes sense, because this is not a blank string, even though it is the string false. Anyway, I could go on and on about like type theory and classes and things like that. Let's talk about actual classes. Classes are basically just a way of combining code in the form of methods and data in the form of attributes, is what we call them in Python. Attributes or properties in general in programming languages, they can mean different things. In Python, attributes are sort of like the member variables. I believe that's the term in Java and other programming languages. And methods are basically just functions that are part of a class. So let's go ahead and look at this program. This is the object-oriented version. I think it's just a little... No, it's pretty much the same amount of code. Oh, that's really weird. But we can see the object-oriented version of Tic Tac Toe has a main function. And when we, instead of having a getNewBoard function, we actually call this Tic Tac Toe board, and that's actually the name of a class. So a class is going to combine functions and attributes together. So the class is also considered a blueprint for objects. Just sort of like, you can think of the class as the data type. So we've created our own data type called Tic Tac Toe board. And just like, int is a class or a data type in Python, but 42 is a particular instance or particular object of this class. We can also create objects, particular objects or instances of this class by calling that class name as a function. And what this does is it will call a specially named function called dunder init dunder. And this is, technically it's not the constructor function, but it's suffices to say it's the constructor function. Other languages will call this a constructor function. When you create a new object of this class, the constructor function is called, and it sort of initializes all of the attributes in that class. So in this case, that's essentially what our getNewBoard function did. So here, you'll notice that there's a special key, special argument or a special parameter right here called self. Let me just catch up on the chat room today, make sure I'm not missing anything. And this is more of a Python thing, having self. Whenever you have methods defined inside of a class, you want to have self be the first parameter inside all of those methods. Self is going to contain the particular object, because remember, this is just defining the class. The class is sort of like a blueprint for objects, and each of those objects are going to have their own drawboard method. And so whenever, say we created like 3 different tic-tac-toe boards, and we called the drawboard method on the first tic-tac-toe board, that first tic-tac-toe board, the object, the value, is going to be assigned to self here. So first we're going to say, hey, okay, so self, we are creating a new attribute, which is basically a member variable called spaces right here. We're setting that to a dictionary. And then we're just running that same code that we have in getNewBoard right here, sort of initializing all those spaces. And we're assigning them to blank right here. And then you can see all of, that constructor function or that init function is indented so it's inside this class. And then we do the same thing with all the other methods. All these methods are part of this class Tic Tac Toe board. And we can tell that because the def statement is inside the class's block, but also they have this little self right here. Now notice main is not a method. It's just a function that is not part of the Tic Tac Toe board class. Right. Oh yeah. Think Dandy brings up a important thing. Technically, you don't have to name this self. It's just a convention in Python, but it's very, very, very important to actually use the word self. I mean, technically, I could change this to spaghetti. And as long as I'm consistently using that throughout this method, then that's fine. This program will still work. But the thing is, every other Python programmer on the planet is going to expect you to use the word self. So go ahead and use self. Let's see, so how can I explain this? Well, here, let me go ahead and... You know what, I don't want to run this. I just want to get an interactive shell. Here's an interactive shell. I'm going to go ahead and create a new tic-tac-toe board by calling tic-tac-toe board. Now this calls that that initialization function, or the constructor function right here. The constructor method, sorry. Technically, function and method are different things. If you get kind of sloppy, you can call them both functions or kind of use one or the other, but technically a function is just a standalone bit of code, whereas a method is a function that's part of a class. And that's, I believe that nomenclature is true in every programming language. That's just like a general programming thing. So now I have this tic-tac-toe board, and if I try to print out, Python will just say like, oh, it's just tic-tac-toe board object at some memory location. But remember, it has this attribute called spaces, which is set to a dictionary. So I could take a look at that. And hey, it's a dictionary, just like how if let me just put a pass statement right here so I don't actually run this program. If I called get new board, except here, B is set to the dictionary itself, whereas B here is set to this tic-tac-toe board, and it contains a variable spaces that's set to the dictionary right there. So there's lots of other methods inside this tic-tac-toe board class. So there's draw board, remember that, so we could say, hey, draw board. And we get that nice little look right here. That's as expected because all of these are set to blanks initially. We could call the setSpace method. The analog of that is over here, the setSpace function. So we could say, hey, setSpace, space5, set that to x. And now if we call the drawBoard method again, hey, that's great. So you can see we've called setSpace on B, and that's affected this tic-tac-toe board object. Now the nice thing about classes is that we could create multiple tic-tac-toe board objects. So let's call this B2 and then call that constructor again. Now I can say, hey, let's set space 9 to O, and then call B2's drawBoard method. And now it's showing us this. We haven't gotten rid of the first tic-tac-toe board object. It's still there, and we can call that right there. But you can see these exist as two different states. Whereas right here, all of this is sort of dependent on whatever board dictionary that we pass to these functions. Now this is, again, the nice thing where if you have a large complicated program where you would have multiple tic-tac-toe boards going on at the same time, classes are something you want to do. You can have multiple tic-tac-toe board objects, just like how you could have, you know, multiple strings. I could say hello for here and then have a different string. You know, the string is the class or the type, And these particular strings are just particular instances or particular objects. Okay, so hopefully, let me see. Is this making sense? I still have a little bit more time. Yeah, Sir Krem, that's this is a just a memory address. This is sort of Python's generic way of displaying an object because it really doesn't know anything about this. We can add, there's a specific method called repr or dunder repr dunder. That's a method that we can change to give a more detailed string. But without that, Python's just going to say, oh, it's just an object. It doesn't really know how to explain it. Now you might think, okay, well, I guess that's sort of nice that we can have multiple tic-tac-toe boards, except it's really not necessary in our small little tic-tac-toe board program. Maybe if we had some like giant game server that, thousands of people could log into, and therefore we would need to keep track of thousands of concurrent games of tic-tac-toe, then having this would be a lot better instead of, like right here, we just have a variable that contains the dictionary game board. So there's no reason, like the object-oriented version of tic-tac-toe here isn't automatically better or worse than this version. It's just that, well, okay, now we have all these methods kind of cobbled together right here. This is actually pretty nice too, just having all the common code. You can notice something with all their analogs over here in the non-OOP version. Notice here we have the drawBoard function, and that takes a board. We have the isWinner function that takes a game board and that mark. getPlayerMove takes a board and player. Hey, notice that we're always passing this data, the dictionary board of whatever the game board is, to these functions. This function and this function and this function. In fact, all of these functions. So it would be really nice, what if this was a much bigger program, and so we had like a ton of code going in here that wasn't at all related to tic-tac-toe boards. It would be kind of hard to find all the functions that are related to this tic-tac-toe data structure, the dictionary that we use for that. So instead, putting that into a class is kind of a nice way to draw that all together. And this way, the methods all work on that same board. It depends on, what object, this object self. So, when we call b.drawBoard, self is set to that tic-tac-toe board object that we've set here into b. And then when we call b2 drawBoard, self is just set to whatever the tic-tac-toe board data structure we've set in B2. Again, we really, in this particular program, we only have one tic-tac-toe board at a time, so it really doesn't matter. I mean, we could just make this like a global variable. In fact, we could totally do that. What if we got rid of this entirely and just said, hey, global game board? And I guess we would need a global game board in here as well. Global game board. And then I'd have to change all of these to use that one variable. So the problem with this, and generally why people don't like global variables and why you've probably heard like, oh, you shouldn't use global variables, is that now this makes it so that the function only works on this particular dictionary that's stored in this particular variable. So it's much less generalized, whereas if we just set this to be like this, now we can pass in any dictionary, and then this works on whatever dictionary tic-tac-toe board that we've passed into it. And then taking that another step further, here we can say like, hey, this is actually a method, it's part of tic-tac-toe board. So here, whenever we call self spaces, that's going to be operating on the dictionary that we set here in the constructor function for that particular object. Yeah, but if so, self is sort of sort of our replacement for, there we go, for that board. So that's kind of another thing. If you see yourself writing a bunch of functions and they always work on the same data structure, whether it's a dictionary or a list or something else like that, that's kind of a sign that like, hey, maybe you should go ahead and combine all of those functions into a single class and just make them methods on that class. Yeah. So I'm not really sure. So, okay, there's also like all the other complicated things like inheritance and polymorphism and encapsulation. And those are concepts related to object-oriented programming. We back in the, I believe it was it the 80s where object-oriented programming really started catching on. Like before object-oriented programming, there was just structured programming and that was basically just using, functions and data structures like, dictionaries and lists and that sort of thing, arrays, which, having functions was way better than having subroutines, which, okay, this is like really going into a bunch of details, or just having like subroutines or go-tos, where basically you just had a whole bunch of code with line numbers and you would say, hey, go to this line and then go to this other line. And that ended up resulting in spaghetti code because it's like spaghetti that just winds all over the place. You had code that was basically jumping around itself all the time. It was nothing but flow control, no data structures whatsoever, really. And so if you had a bug at some certain point, it'd be kind of hard to trace, like, well, how did the execution get to that point? It could have been jumping around wherever. Whereas with functions, remember, functions will remember what line called them because they need to return to that line after the function returns. So if you have a function that calls another function that calls another function, and then you have some bug or exception that happens there, then you can actually see in the traceback, like, oh, this function called this function, that called this function, and that's when the bug happened. That gives you an idea of where the code has been, like what the flow of execution was, and that can give you a better idea of like, oh, how did this go wrong? Oh man, design patterns. Yeah, so anyway, about inheritance and polymorphism and encapsulation. Um, those are like the three terms that everybody learns about in their like freshman computer science or like reading their first Java book or something like that. Inheritance is people kind of got really. Inheritance later turns out to be a bad idea. Let me just put that out there. But say we wanted to create like I don't know, a Tic Tac Toe board, except it had a different draw board. Like I didn't like how this looks. I actually wanted it to print out something cooler than that. Like maybe I wanted to make it way bigger or something like that. Here, I'll go ahead. But I wanted to keep everything else about Tic Tac Toe board except for this one method. I just wanted to change how it's drawing. Instead of copying and pasting this entire class, and remember, copying and pasting is generally a no-no, because that just creates duplicate code. Instead, you could create a new class. Let's say class, I'll just call this big board because I'm going to draw it way bigger. And then I can say, hey, this is actually a subclass of Tic Tac Toe board, which means that this class, if I just left it like this, it would be the exact same. It would have all the same methods and attributes of Tic Tac Toe board. But now I can overwrite any of the methods and change those. So, hey, I want to create my own draw board. Is that the name? Yeah. And here it's going to be like this, except I want this to be slightly different. I want it to be like, let's do this. Add 2 there. I want it to be like instead of a single character, I want it to be like a 3x3 grid of characters. And I'll show you what I mean when I'm done with this. Bam. Making that super big. making this super big, and so I'm printing each of these 3 times. Go ahead and copy and paste this row. I don't want to duplicate that though. So it looked like this. And now let's change it so that instead of creating a tic-tac-toe board, we're now creating a big board. Notice the only method that I've implemented here for big board is draw board. But because it's subclasses, or it inherits from tic-tac-toe board, you can consider this to be like, oh yeah, it has all the same methods that tic-tac-toe board has, except for draw board. We've overwritten that with our own method. And also I've changed the main function so that now uses big board instead. So if I run this again, you can see now they have huge, big, really huge tic-tac-toe boards. So I can say like, I'll go, X will go into the center. We're filling all of that in. And O goes into the top left, and X goes to the very top right here. So this is a way that we can use code reuse. Code reuse was also a big thing because, you know, code is actually pretty expensive to write. Like you have to, it takes a surprising amount of time to write programs, and software engineers are really expensive. So, you know, if we could just reuse the code that they've already written elsewhere, then that would be, you know, a huge amount of savings. It turns out that really you don't actually use code reuse. Like, other people have implemented tic-tac-toe in Python. I'm not reusing their code here. I just wrote it all myself. But in this case, you know, we're inheriting from tic-tac-toe board, so we're reusing all the code that's in tic-tac-toe board, except for this draw board, which is the one thing that's different. So that's what inheritance is. The problem with inheritance, and why you really shouldn't use it, is that it kind of limits you, actually, because what if later on we say, hey, I want to do a bug fix or change how tic-tac-toe board works, like change one of these methods like isWinner or something like that. Let's say we wanted that change in tic-tac-toe board, but we didn't want that change in big board. Well, that's too bad, because big board will always inherit from tic-tac-toe board. We'd have to, like, you know, say we made some change to isWinner, but I didn't want that change inside of big board. I'd have to like, go back and copy and paste the old tic-tac-toe board's isWinner method here. And this can, like, now we have like duplicate code, and it's kind of weird and can become sort of a maintenance nightmare over time. So because inheritance sort of locks the children into accepting any changes that are made to the parent later on, it turns out inheritance is kind of bad. Whenever inheritance is discussed in textbooks or tutorials, you'll always, like, you get the same, I really hate these. They're, let's go open test.py. They'll always say like, oh, well, you could have like a mammal class and it does stuff, and then you could have a dog class and it inherits from mammal because dogs are mammals. And then blah blah blah. And these are such artificial usages of the class, which is why I really hate them. But you know, like, and then mammal is subclass from the animal class, and we add a whole bunch of stuff to this. But like, here's an idea, like, well, hey, mammals that lay eggs, I guess, like platypi. Platypus. Lay an egg. Or something like that. Whereas we have like bird, which is also a type of animal. This is weird. Like platypuses are mammals, but they have things that are like that are bird-like. You know, like birds are gonna have a laying egg thing. So you might think like, oh, maybe I should actually make this subclass bird instead. But then there's this sort of confusion of like, well, it's kind of like a bird and it's also kind of like a dog in some aspects. Should I just call it a mammal and then just copy and paste all the egg laying code here? This is being really abstract, I know. But this is the problem with inheritance, is that your code is not always going to be such a nice, neat, orderly hierarchy, um, because we're constantly making changes to code, either for bug fixes or for new features. And so using inheritance kind of limits us. Python does have multiple inheritance, and I don't know enough about it off the top of my head to go into it. So, but this adds its own like a lot of its own complexity there. So I think instead of inheritance, a lot of people go for composition instead. In Java code, you'll often find like classes that implement interfaces, which is sort of like inheritance, except it doesn't directly tie it to any particular method. This is probably like going way off topic. I'm already above 2 hours here, so I kind of want to wrap up this stream pretty quick. But anyway, inheritance, kind of overrated. That's the takeaway from that. Encapsulation. There's inheritance, encapsulation, and polymorphism. I'll go into polymorphism. That's basically where let's do this. Pass. Okay, polymorphism. So we have board 1. We're going to call that a Tic Tac Toe board. And we have board 2. We'll make that a big board. Polymorphism basically, well, poly, many, and morphism is, I don't really know like a good way to define this. It's basically a way of saying, hey, since big board inherits from Tic Tac Toe board, you can also consider big board to be a Tic Tac Toe board. So we have this instance of function in Python, which can return true or false. We can say, hey, is 42, is that an instance of an integer? Wait, oh. Type of? No, what is it? Is this some, oh, this is really embarrassing. Okay, time to Google, which is basically what all programmers do. Instance of, is that a JavaScript thing? Is instance, right. Okay, I totally forgot that. Yep, I'm a professional Silicon Valley software developer. Okay, is instance 42 int. This function will return true because, hey, 42, yeah, that is an object that is an instance of the int class or the int data type. Let's go back here. We can also say, hey, is instance is a B1, is that an instance of Tic Tac Toe board? And notice how we don't have the open and close parentheses like we do right here. We're not calling the constructor. We're just referring to the class itself. And hey, yes, that is true. How about B2? And B2 is an instance of Tic Tac Toe board because big board inherits from Tic Tac Toe board. So all big boards are Tic Tac Toe boards as well. It's kind of like how all squares are also rectangles, or like every square is a quadrilateral, I guess. But not all quadrilaterals are squares. Like, rectangles are not necessarily a square. Yeah, that's how that goes. Right. We can see that here. Is instance is B1. Is that a big board? And we'll say no, it's not. Because Tic Tac Toe board, doesn't inherit from big board. So it's not big board is a type of Tic Tac Toe board. Tic Tac Toe board is not a type of big board. That's basically polymorphism is basically, hey, you can treat all big boards the same as a Tic Tac Toe board. So a big board can be considered a big board. It can also be considered a Tic Tac Toe board. So if you ever have any code that needs to, like every property that is true about Tic Tac Toe board is also true about big board, Except that's not really true. There are exceptions to that. Yeah, uh, object-oriented programming is overrated. Inheritance is especially overrated. And then encapsulation, that's basically just, what's a good way of putting that? There's getters and setters, I guess. So let's think about this. We have strings, right? Hello. And we can use operators like plus to do string concatenation. And the plus operator can also work on integers as well. But you can't add a string to an integer. But you can do list replication with a string and an integer. So, there's certain things that strings can do. Let's go ahead and, I think I'm setting myself up with a really bad metaphor, but let's go ahead and create a class called, okay, well, actually here, let's do the non-object-oriented version of this. Let's say we have a variable called bank account. It's set to 0. And then we, have some code later that says, plus equal, I deposit $400 there. Print your bank account balance like that. In a much bigger and more complicated program, you're going to be doing all sorts of things to bank account. And let's say you have like some code where it's like, oh, bank account equals the platypus. Now this is obviously going to this is going to be some bug, but Python's not going to crash. It's just going to dutifully carry out all the instructions that you've given it. So we could create a class called bank account. And this is just a convention in a lot of programming languages, including Python. The names of classes always begin with uppercase characters, whereas variable names usually just begin with lowercase characters. We could say bank account init self value self. So let's say balance is going to be equal to value. And then we have deposit self amount self dot balance plus equals amount. And then we could also add some input validation code right here. So if not is instance amount int raise value error. That is incorrect. Oh, or must deposit an int. And then we could also have something like withdrawal. And that would basically be the same thing except minus. Oh yeah, and then also display balance. Print self.balance. Okay, now we have a class right here that has a bunch of methods. Remember, classes are just combining data with methods right here. So code and data values right here, or attributes in this case. Let's create here we go. Here, we'll create a bank account. We'll set it to have $666. Now we could say, hey, display balance. And that'll print out the balance right there. I have godlike focus because I'm also not like checking out the chat room. And also, I love just talking to myself. That's great. Account, let's deposit, $100, $111, and then display the balance after that. Then we have 666 and 777. Everything is working great. What if we tried to deposit platypus right here? It would be 666, and then, hey, we're going to raise that value error right here. Now, crashing our program because we raised an exception, that's bad. but it's much more preferable than having our program not crash and just continue even though there's clearly some bug running, because then, the longer the program runs after that bug has happened, the more things that it could start wrecking all over the place. So, it's actually a pretty good thing that this has changed. Now, notice how in all of this code, we're not actually changing balance here at all. I mean, technically, I guess there's nothing to keep us from just going balance equals, a lot of money right there. So technically we could add, in other languages, there's a concept of public and private member variables and public and private methods. And if a method or an attribute or a member variable, in this case an attribute, is private, then code outside of the class won't be able to affect it. So like here, like the compiler would keep you from compiling a program with code like this, because it would say, hey, balance is actually private, so you can't run this. The only way that you can change balance is by calling these public methods, which change the balance. And here, they change the balance in a controlled way. Like they check, oh, okay, you can't just enter anything for amount, it has to be an integer. Or like for right here, we could say, hey, if amount is greater than self.balance, we could raise another value error saying, you do not have enough money. Or so basically we can like write all sorts of code that acts as safeguards for this balance right here. Now, Python doesn't have private members or private attributes or private methods. What Python does have is this convention where you begin it with a underscore, and that's basically kind of a sign to programmers like, hey, don't write code that touches this. The only code that touches this attribute should be the code inside this class. So if you're just writing code that uses this class, don't actually directly change balance. Now it's there's nothing to actually keep you from writing code that does touch it, but it's sort of like a buyer beware. Your warranty is void if you crack the case open or something like that. But as long as we just call the methods, then this code will always be working. Even if we do something illegal like this, at least it will raise an exception saying, hey, something went wrong, as opposed to just carrying out your actions. Now, again, we don't need all of this code. We could just have, a variable called balance and just set that to 666 and then, balance plus equals 100. But there are so many more things that can go wrong because we don't have the safeguards here. I mean, we could write code like amount equals 100 and if not is instance amount int, then, blah, 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 do a whole bunch of things. But we would have to write, this code every time we do something like right here. That would be, a lot of copying and pasting that we'd have to do. Instead, undo. Instead, if we had something like this, we're kind of hiding away this variable balance away from the person who's just using the class. So this is what encapsulation is, I think. Oh, wait, am I actually doing this completely wrong? What is encapsulation? I think encapsulation is where you set up your code so that people aren't directly acting on like this variable. And instead, this class encapsulates that variable, and you only interact with it through these methods, which provide very safe ways of affecting this data. Like in this case, there's no chance that balance can become negative because we have this check right here. Oh, you can't withdraw more than you have in the balance, unless you're a super badass hacker like me, because I'm like, haha, I'm gonna hack this bank accounts by depositing a negative amount. because the people who implemented this code forgot to check there. So now it's going to, oh wait, no, I'm going to withdraw a negative amount. Ha! Because they didn't check, because, negative 1,000, that's not going to be greater than the balance of the account that I've set up. So it's going to be like, okay, perfect. We'll just do that. Oh, whoops. Forgot to add a thing there. So bam, I've just added $1,000 because I've hacked the matrix or whatever. And so then we would have to say, oh, that's terrible. Let's add some code that stops that. Something like that. And that's basically what hacking is, before this code was here, technically, this was totally allowed by the code. It's just not what the original programmers intended to do. It's kind of like coming up with a legal loophole. You're still following the law, technically, but you're abusing the law in a way that the people who wrote the law, or in this case wrote the code, never intended it to be used like that. Yeah, so now if we try to run this, it just raises an exception. So yeah, encapsulation, it's basically we're, encapsulating this variable. I think that's what it means. What does encapsulation mean? I don't know. You never really use it in professional software development. Here we go, computer programming. Is used to refer to one of two related but distinct notions. Yeah, people use it for different things. Restricting direct access. Yeah, so that's in languages that have private and public member variables or private and public attributes. If we made this private in some other language, then we wouldn't be able to, like, the compiler itself would prevent us from compiling code that touches that. Or bundling of data with methods that operate on that data. Yeah, so just like our deposit and withdrawal methods operate on the balance, the underscore balance member variable. Okay, yeah, so I remember this. It's all up here. I learned this back in college, and then I don't know, it's, the technical term is encapsulation, but in real world programming, you just kind of think of it as, oh, it's how you write code, because it's a good idea to write code that way. You just write code that way for so long, you forget the original term for it. So yeah, inheritance, encapsulation, polymorphism, those are the big things about object-oriented programming. But remember, you don't have to make everything an object. I just see a lot of people who, where was it? Was it here? Oh. Who, start creating these elaborate hierarchies of classes that depend on each other. And, it's just a lot of bureaucracy. It's not organization. Now, in much larger programs, it becomes more important. Like, okay, you should, take the time to organize all your code and data into classes and that sort of thing. And, make it easier to, especially if you have multiple people working on the same software project. It's a great way of sort of dividing up what does what. And then there's design patterns, which is really, it started off as like a Java thing, but it really does apply to all programming languages, mainly the Gang of Four book. Yeah, this one, called The Gang of Four because it was written by 4 people. Design patterns. It's a sort of a lot of best practices with object-oriented programming. Basically, it's about Java, which is a language where, everything has to be in a class. And I think Java really overuses object-oriented programming. One of the nice things about Python is that you can have classes in your program, but you don't have to use classes in your program. And oftentimes, it doesn't make sense to have everything in a class. Oh yeah, I remember I have heard of that. There's some talk called Stop Writing Classes. I think this was a PyCon talk. Yes, by Jack Dietrich. I think I went to this. Oh yeah, this was in the time it was in Santa Clara. 2012? Really? Wow. I'm old. Anyway, yeah, this is great. I'm gonna go ahead and paste this into the chat room. This is great. Yeah, Python is a language where you don't have to put everything into classes. Like a lot of people who first learn Java, where everything is object-oriented, and then they learn Python, they start writing their Python code as they would write Java code. And so they instantly start off by creating all these different classes and then filling in with methods and things like that. And it's really just overcomplicating their source code. So yeah, this is great. Thanks for the recommendation. Anyway, let me go here. So yeah, this isn't too bad. I mean, it's kind of nice. This is literally the same number of lines because it's so directly analogous to each other. Oh, almost the same number of lines. But it's pretty easy to see the sort of like one-to-one correspondence between the object-oriented version and, oh, I guess I have these. Oh, that's right, I added this big board. Let me get rid of that. Oh yeah, it is the exact same number of lines right here. But I'm going to go ahead and, let's see. I will select all and copy. Actually, you know what? I don't have to put this onto Pastebin because it's already up on my GitHub account. In here in Python Standard IO Games, here in Source. So in here you'll find a Tic Tac Toe program and then a Tic Tac Toe OOP program. So you can check out both of those. Here, I'll post the link into the chat room. All right, so I've been streaming for nearly 3 hours, and I think this is the part where I should... This is the part where I should say, cut off for the YouTube video. Wow, I originally thought the YouTube video would be like an hour, but I guess I really like rambling. So thank you for watching this video and sticking with it. I'll try to edit this video to make it a little bit more polished. But yes, thank you very much and have a great, good luck programming. Okay, yes, I will now cut this off right here. I should probably, I'm just gonna like minimize all of this. Yeah, oh, okay, hey, thanks everybody. I am tempted to like keep streaming, except, I don't know, oh, hey, thanks everyone. I am tempted to stream, but I also have like a whole bunch of other work that I need to get done. So I'll probably just, I'm going to be out of the country for the next like 3 weeks, starting next week. So I'll probably stream like a couple more times. Usually this is my stream. Be sure to, smash that like button or whatever Twitch has, the follow button, I guess, if you want to become a follower, such as what SugarLumps13 has just done. Thanks for the follow. And also thanks to all the other people that I wasn't paying attention to also followed, like The First Glitch and XDCF and Fafi Skimshra and Reverend Legend and Raiden Bates and